All right, welcome back. We're going to leave the world of GUIs for now and talk about something different. We're going to talk about threading in Java. In operating systems environments, we usually have a notion of what are typically called processes. So if I look on the Linux server right now, there's over 200 processes running at the moment. Or 200 processes sitting out there. One of them is actually running. Most of them are sleeping. But sleeping processes are mostly waiting for some event to occur, a timer to expire, a piece of input to arrive from somewhere, and so on. So one of the features of Java is that it supports its own version of processes, what we can think of as threads. And we can write, a method in Java that's going ahead and executing some things, but we can have that method also create a totally separate execution context in which another set of code can be executing simultaneously. So in C, we talk about fork as a way to create a clone of a process, and execl, execv, and so on to change what a process is executing so that we can run parallel code. So in Java, the notion is a thread. So let's go ahead and play around with this. And let's make something called myThread. Well, I didn't need a main method here. Let's make a class myThread, and I'm going to say extends thread. All right, so what is a thread? It's a class in Java, right? We know now most things are classes. And we can create our own class that's an extension of a thread. And there's not too many pieces that come to it. There's a handful of methods available. The method we're going to be most interested in is called start. And let's see what this does. So I'm going to make a class myThread, and I'm going to make public void run. And I'm just going to do the following. For I equals 0, I is less than 100, I plus plus. And I'll just print out 100 integers, and then I'll print out a new line. And that'll be the end of our run method. So this is a very simple class. It has one method called run, takes no arguments, returns nothing, and run simply prints out 100 integers side by side. So I can compile that. And let's look at our main method. And let's create some mythreads. So mythread mt1 equals new mythread. And then let's just call mt1.run, which will, call the run method in this thread. So we can compile that. Let me hop on the Linux server. And so when I run main, it prints out the numbers 0 through 99, exactly what we would expect. All right, so let's make a few threads. And compile that and run that, and it prints out the numbers 0 through 99 3 times. All right, still nothing too surprising. Let's do one more thing. When we construct our thread, let's pass an integer. And let's pass an ID to the constructor. And so in here, let's make an integer ID. And let's make a constructor. So here's our constructor. This would be public myThread. And we'll pass an integer ID to it. And we'll save it. We'll save this for later use. And in our run method, when we print out our integer, we're going to actually print out ID, followed by a colon, followed by the number I, followed by a space. So if we compile that up and we run our main program, we see thread 1 printed out the numbers 0 through 99, thread 2 printed out the numbers 0 through 99, and then thread 3 printed out those numbers. All right, so none of this is particularly unexpected, right? Because our main method is, just calling the run method in these 3 classes. There's nothing thready going on yet, but I'm going to make one change here. Instead of calling the run method, I'm going to call the start method. And what is that going to do? We haven't defined a start method in here. All we have is a run method. But there's a start method in this thread class that we're extending. So by just changing the call to run into a call to start, let's recompile main. And then let's run main. And now we see something very different. We see that thread 3 was the first thread to do any output. And it output consecutive integers starting from 0, going up to 25. And then all of a sudden thread 2 started doing some output. And it output integers from 0 up through 42. And then all of a sudden thread 1 started doing some output. And it began outputting integers 0, 1, 2, and continued all the way up to integer 67, at which point thread 2 came in and continued from 43. I guess thread 2 did something earlier, did 41, 42. So it continued with 43 and did some more output all the way up to 81. And then the thread 3 kicked in and started outputting again from 26. And the first thread to finish was thread 1. It finished right here, and then thread 2 picked up at 82 and finished, and then thread 3. So these 3 instances of the run method were running simultaneously. And even though, we called thread 1 start method first, thread 3 is actually the first one whose run method began to execute. So when we look at the documentation on a thread, if we look at this start method, it says causes the Java virtual machine to begin a new thread, basically, and that thread will execute the run method in this class. So when we say start, 2 things happen. 1, we create a new thread, a new execution instance, and 2, in that thread, the run method is called, which in this case, is this thing right here. Now, we don't write the code for start because start has to do a lot of stuff before it calls run. It does whatever has to happen to create a new thread, and then it calls run, and this comes back right away, and we can add a print message here. And we'll just say main is done. And if we run this, before any of the threads started doing any output, it said main is done. And then, a little while later, the thread started getting into their run processes. And again, thread 3 was the first to finish, but in this case, thread 2 was the last one to finish, whereas previously it was thread 3. And if we run this again, this time thread 1 was the last one to finish, and thread 2 was the first one to begin. So this is truly asynchronous, right? It's very hard to predict exactly how things are going to be executed, in what order, and when the CPU is going to switch from one thread to another. Now on this machine I've got multiple cores, so these threads could be running simultaneously. Um, but on a single CPU system with a single core, it would have to time share between the different